Hello, good afternoon for Europe, for everybody else, good day. And today, as Nick said, gonna discuss things to deploy to your Nomad cluster. In the modern world, that looks a lot like this nowadays. This is actually the picture that is still behind me. Crazy clusters, containers everywhere. And when you deploy, or even after deploy, it can quickly turn into a murder mystery, basically. Whereas my stuff, does it actually work? Does it run in the way I think it does? Does it actually run in the place I think it does? And how much catastrophic failure can I survive before I need to call my boss and saying we're losing revenue? That's, of course, always something we want to avoid. So today we'll discuss it in the context of Nomad. Let's first step back. Like, who am I? I went to university to become a molecular biologist. I worked for some of the biggest pharma companies in the world. And big data became a thing back then, which means at some point I was creating 1 million data points per week, which I required to do some statistics / development for, or coding for. Turns out I was a lot better at that than creating my own data. So according to my colleagues, I sold my soul and became a developer. In an academic world, most of the time you are the one development guy is also the server guy. So I learned to do academic clusters, our own servers, and that's how I got hired into Inuits, where I'm an open source consultant in the DevOps automation world. And according to my colleagues, I've once again sold my soul to the dark side, become an operations guy. So I said complexity with containers. And today we're going to discuss it in the context of Nomad. For those of us that haven't heard or haven't used Nomad yet, is the HashiCorp container scheduler that can schedule containers, but it can also schedule Java things or execute anything pretty much on your disk. And it has plugins that basically can you can plug in basically anything that is schedulable and that you want distributed across your network. And Nomad has very nice integration with other Nomad properties of tools like consul, like Vault. So if you like vendor locking, then this is the place to be. And it's not vendor locking as such as the old school, but the tools are so well integrated you actually want to use those. What does a Nomad job look like? For those of us that are used to Kubernetes, this is not YAML. It is written in a DSL called HCL, the HashiCorp configuration language, and deploying a simple container workload looks like something like this. It's of type with the name, so in my case blog. I want to deploy it somewhere on any of the 2 data centers that I have defined in my local lab here at home. I have 2 data centers, one's called Waldorf, the other one's called Stadler, named after the 2 the angry Muppets in the Muppet Show. My job is of type service. There's a couple of types. One is badge, and you can also make sure that something runs on every node in your Nomad cluster. But in this case, I want something of type service. I'm going to group some jobs together, tasks together. And one of the tasks being Nginx. This is my little container that has my static block inside. And it's going to be of type, the driver is going to be of type Docker. And I'm going to expose something on port 80, which has a... Plus, I have a local job, 2 data centers. It's of type Docker, and it exposes something in port 80. when I put this on my hardware, on your hardware, we're not covering any of the following problems. My hardware could fail. The underlying operating system can fail, and of course this never happens because we all write perfect code, but we could possibly potentially push broken code, or we have some form of peptide in the middle, like just now, where stuff just doesn't happen the way you think it would happen. So you need to cover yourself for these eventualities. And from experience, they will happen. So you need to build these in from the get-go when you're experimenting, even with setting up new infrastructure like Nomad. So to cover the first one, I want to make sure that I have more than one instance, which means that one can die, the other one will still be able to fulfill any requests that are coming in. That's fairly easily done. We add a little code snippet that says, I want two. The capital is my mistake, so it's lowercase. But that still doesn't mean I know for sure that the underlying hardware is going to protect me, or the spread is going to protect me, because Nomad could potentially schedule the two instances on the same Nomad client. So actually you need to force Nomad to schedule it onto different hardware. And this can be done by using the constraint resource in HCL or Nomad. And by this little code snippet, I actually force it onto different hardware, basically saying the operator of type distinct host needs to be true. So if I have two instances, I'm forcing it onto different hardware. Of course, there's more than just different hardware. There's also different locations. So I can have different data centers. That can be done as a defensive strategy, saying I need to be able to survive an entire data center going down, or actually have data centers nearer to the customers that are just now waking up or just now logging in. So I'm actually shifting load towards those people. And we can use this by using the spread resource. And in this case, I'm spreading across data centers. Spread, as the title of the slide suggests, is just a suggestion. So whereas constraint will actually fail if it fails to schedule it onto different hosts. When spread, when Nomad can't fulfill a spread, it actually will just continue deploying and scheduling nodes. So it will try, but it will not fail upon a failure to schedule. So that's something to keep in mind when you are spreading. So you can survive a data center being down, but you are needing more than you need a certain amount of instances running. So Nomad will quietly schedule those in non-preferred data centers for you. But that also at the same time means you can have an unpredicted unbalance in your schedule. So you need to have other tools to look after those and reconcile later, or manual, or when your other data center or your other condition comes back online. We can also schedule based on metadata. So this is a little snippet of the client configuration where I basically say this particular client is in a rack of his. There in my house, there's a his and her rack because the office has two workspaces. And I actually spread the load across those racks. Of course, in my lab, my home lab, there's only one power line coming in. So this is purely for experimentation. But if you run a professional data center or multiple data centers, you'll have multiple racks. So this way you can spread across metadata you inject into your clients. And this brings us to consul. Consul is the load balancing tool that HashiCorp has created, and it can actually be used as a DNS endpoint, so I can dig my local console node. It also has a key value store, and it well, no longer recently, but it has gained the functionality to be a mesh, so we can separate stuff from each other. And since I think Nomad 10.4 came out today, and we can actually use the ACLs now as well in Nomad. So what does that look like in the Nomad space? Inside my task, I add a little section that is called service of name blog, and it needs to check my port HTTP, which we can remember from the definition before. So HTTP stands for port 80 in my case. And we need to check it. We need to check if something is available on TCP. We do it every 10 seconds, and not to kill off our infrastructure. We fail after 2 seconds. So now we can actually have Nomad and console working together to work out if my service that I've just deployed is actually working. So we're working towards, is my node actually providing the service I expect it to? We can actually prevent Nomad from restarting, and therefore killing off any CPU cycles we got left. So inside our check, we can define our limits for how many times we're allowed to do a check before we're registering a fail. In this case, we're checking 3 times while ignoring warnings. So normally it wouldn't ignore warnings, but now it will, as defined here, it will only basically crash out on criticals, and we'll have a grace period of 10 seconds. So we need to wait for 10 seconds before our first check comes in, because containers might need a bit of time to actually boot up the process that is running inside. And in our case, if it fails, we want it to have restart, but not that many times, because after 2 times, we're fairly sure our code inside the container is broken. You might want to try it more often than that, and we'll delay a restart for 15 seconds and we'll crash out with a fail. And this allows us to set up rescheduling. Basically, when it crashes, or when it fails, errors out, or somehow the underlying infrastructure kills, for instance, your Docker container, you can wait for a certain amount of time and then try and reschedule your job. In this case, we'll reschedule, waiting for an amount of 30 seconds, and in our case, we'll have a constant delay between rescheduling. So it will try again, and there's 3 delay modes. Basically, it's constant, which is a steady interval; exponential, where it will eventually, the interval will get longer and longer and longer, or the Fibonacci, which is another way of making intervals longer. In this case, it's set up to true because constant, but especially with the exponential, with the Fibonacci, you might want to switch that over onto a parameter called max delay, which is, as the name suggests, is the longest waiting interval you want to schedule for. Because otherwise, exponentially, wait times will get to a time so long that it actually makes no sense to wait anymore. So for exponential Fibonacci, you want to set a max delay. You can test everything we discussed so far. We can basically, we can actually test pretty easily, either by injecting something called a dummy service, which is a little tool that allows us to schedule or configure information of a period where a service works or service fails, and then we can see how Nomad reacts to it. And the extreme version of that is ToxiProxy, which is a tool came out of Shopify, which basically allows us to inject any bad behavior we like. So we could have delays, we can have wrong HTTP endpoints, and we can, this way we can test our assumptions and our service checks. And this brings us to deploying our code and hoping that we deploy correctly working code. So let's bump the number of blogs instances we want to about 10. And if we configure the update resource, we can basically say we control the behavior of Nomad, how it reschedules and how it takes an instance down and brings up the next one. In this case, I've defined I want max 2 in parallel. So it doesn't take down all 10 at once and brings up the next 10. It will take down 2, it will bring up 2, it will take down 2, bring up 2. And we can tweak how long we expect this to take. We can tweak how long it will be expected to take for something like the whole process, or we can tweak how long it will take for a new node to come online. And that nicely leads us to blue-green releases and eventually Canary releases. So we can tweak our settings a bit more. So in my case, I'll say now I want 1 in parallel, and I need to wait for all 10 to be healthy before you switch over. In blue-green releases, as we know, there can only be, there's multiple versions online, but there's only one active version. And by saying we'll wait, Canary equals this, the same number as we defined for count, we make sure Nomad waits for all 10 to be online before switching over. Auto revert is true, so when it fails, we'll automatically flip back to the old version, and we'll auto promote is false. So we basically will have to have a manual intervention or a programmatical intervention based somewhere from your CI system or from a person basically saying this is correct. We can move on. This also brings Canary releases. So in Canaries, we'll have a Canary number that is lower than the amount of the count. So we'll bring online like a few instances of the Canary or version, the next version we're bringing online. And in this case, we'll just auto promote if it succeeds, and that way we'll keep going, and automatically we'll eventually have the new version online. This brings its own problems, so we can make sure that we by using tags, we can make sure that we distinguish between the current version and version n+1. In this case, we'll add a version 2, which we can programmatically add to our definition by using templates. Which means we can, so we want to, in this case, we want to investigate if our Canary is actually doing what it's supposed to be doing. Auto promotion, if you have it turned on, you basically assume that the only way it will fail is catastrophic failure, which Nomad will pick up and then auto revert. So if we're not entirely sure or have intrinsic tiny changes, we can set it back to false, and then we can use consul actually to a new feature in consul to tweak the traffic that is going to our new version. Had to mangle this code a bit to get it onto one screen, but basically we can configure a service router in console of type blog, of name blog, and we set up 2 routes. And the first one is the default route, and then if something has a tag called v2, then we'll move it onto the new service, which is a copy and paste pull, but that's the server should have been blocked and then version 2, so we can then start tweaking the ratio of stuff going over. Then the next one is actual the case where we see so much success basically on your platform that we need to add new hardware. And it's either because it's so successful because we're loading so much tasks and groups on it, or people are excited to use our service. So there's a tool called Sherpa, which is written in Go, which we can use to monitor the Nomad resource usage, and we can based on the Nomad provided metrics, we can actually start scaling jobs. And we can set it up in such a highly available way and fault tolerant way that Sherpa doesn't become the singular failure point. And the next version is, my platform was so popular, so we're scaling jobs, so actually my clusters start filling up. And for that, James has created a tool called CamTrail, which basically allows us even to scale our nodes in our scaling groups, or whatever backend you're using. But we can scale, we can actually tell AWS, for instance, that's the common one that's built into CamTrail, please extend my auto-scaling group to allow even more nodes to be brought up into my cluster and allow it to schedule jobs on there. And that's it. That's me. I'm Bram. You can email me, and I'm pretty much attachment genie on any social media out there. I'll put these on SlideShare and on the slides on SlideShare and on the discourse group.
That was awesome. Thank you so much. A lot of great folks getting excited over on YouTube as well. So Bram, if you have the time, I'm sure there'd be some love for you to head over there and answer some questions.
Okay, I will.
Super interesting. James Rosell is going to be, you can't give that man too much credit. He just gets too excited about this. But it's a great, isn't it a great product? Great
It
tool.
is amazing, yes.
You know, James now works at HashiCorp, so
I
I'm
did see the
kind of
tweet,
excited to see some wonderful things now.
Yes,
we get to pay him for a living. It's dope. But next up, well, just kind of coming up in about 5 minutes, but I don't know. Are you all right to stick around and chat for a bit, Bram?
for sure.
Oh, cool. Yeah, because we got Giuseppe coming up in about 5 minutes, but I'd love to just kind of ask you a few questions about the stack. You're using this at pretty big scale, right?
No. It's the official answer. So at home, there's 4 NUCs, which I can pretty much kill, and we're running on some virtual hardware. So we're not running racks. We're hoping to run racks. We're currently in a phase where we're doing a shootout between Kubernetes and Nomad. Yes.
You're not allowed to say those words on this. This is HashiTalks.
Yes. So the continuance of that is Nomad is winning, hands down.
That's awesome. Hey, I love the fact though, and this has kind of been some of the chat that's been going on over in YouTube around the IoT use cases, and I think one of the for me the cause around the versatility, right? I mean, you said it yourself. You're running on Intel NUCs. You're potentially going to run it over in racks. I know things. Yes. There's ARM binaries. What kind of is that like a really, is that's important to you?
Yes. Software will eventually work hardware will eventually fail.
Right.
We have contracts where we guarantee uptime. So things like diggers digging up the data line just outside your office is something we need to think about, which people pay us for to think about. So things like scale, like how does it work in a different data center? Latencies are a thing.
Yeah, it's really important to kind of get all of that evaluation sorted up in front. What I suppose kind of like, how's the evaluation going? I mean, is there anything that you could share around? Because I think it's important that people do fairer assessment. I mean, I'm flippant and I joke, but you know, I dig Kube. I just think, is there anything you can share for folks when they're doing their evaluations between different schedulers that you've kind of experienced on the process that may be useful?
We have nothing out in the open at the moment. We pride ourselves on being an open source company, so we'll definitely in some way open our result set. This talk is one of those. Basically, how do we schedule things in a way that survives? But there will definitely be a blog post about the shootout.
I will look forward to that, and maybe we can see you back here again next year.
That would be lovely.
But not with that K thing. It's only with the Nomads.
Okay. Yeah, that for sure. I'm 100% team HashiCorp, so that's.
I literally, sorry, I apologize to anybody who's watching. I'm absolutely flippant, but genuinely love Kubernetes, and I would love to see you come back and talk about the results of feedback and things, whichever way.
Yes.
I think it's just genuinely interesting. We've got to be thinking about them workflows. It's not about the tools and tech.
True that.